Well, hello, ninth grade. This is our last of the three little talks we'll have over the most complex vertebrates on the planet. So here's class Reptilia, something that you're very familiar with. Class Reptilia has an ancient lineage going back for a very long time. Here's a primitive reptile known as Samoria. It's a body plan that you would recognize. And in Latin, they were referred to as squamata because they squat, their legs are splayed out to the side. So reptiles do a lot of work for us in our story of how complex life moved from water to land and became dominant on land. And reptiles, surprisingly, have given rise to a number of different forms, some of which still remain today. So one of the things I want you to notice here about class Reptilia, if you look at this branching tree, we've moved all the way through these, and so there's reptile in white. And then next to it is mammals, and you might be asking, where are the birds? Well, reptiles, birds, and mammals are all amniotes. They all have keratinized, waterproof skin. They all produce some sort of external covering, be it scales, feathers, or hair. And they all do internal fertilization. Reptiles and birds give birth, have external eggs, right, that they have to hatch. Reptiles have a leathery egg. Birds use a calcium egg they pull from their bone. Some mammals still lay reptilian leathery style eggs. Only a few kind do, but mammals move that process internally completely inside their body. And so anyway, birds fit within reptilia, which is a new idea for you, and reptiles and mammals form sister clades. They diverged a very long time ago. Both are very ancient forms of life alongside each other. It's just that they had different heydays or different periods of dominance on this planet. One of which you know of as the dinosaurs, archosaurs, pterosaurs, plesiosaurs, ceratopsians, velociraptors, hadrosaurs, you name it. Here is that reptiles had a lot of different versions, forms, body plans. They had a long history and a lot of experimentation done to where they worked out a lot of different body plans and for a lot of different environments and niches and strategies. And so there's a lot of them that we don't have anymore, obviously, but some still remain. So what I want you to know is class Reptilia is what's called paraphyletic. It's got all of its branches, or at least members of its branches, remaining. So if you look at this, the leftover archosaurs are the crocodiles and alligators. And then you have, the typical reptiles over on the left, the Tutara lizards of the ancient forms. Then the theropod dinosaurs, the Saurischia, you have birds left. And then you don't have any plesiosaurs or ichthyosaurs, but you do have snakes left. Turtles are the only dotted line on there. They have a really strange lineage. We don't know exactly who they're closely connected to, but they are reptiles. And so class Reptilia is paraphyletic. It's got some remaining members of each of its branches. So as I said, dinosaurs, birds, and lizards all are very closely related, and they are all diapsids. If you look at this picture, they have two holes in their skull. Mammals are synapsids. They have one hole in their skull. So the synapsids and the diapsids split a long time ago into mammals and reptiles from a common ancestor. The anapsid, well, that's your turtles. They're just weird, and no one really fully understands their lineage. So the general characteristics of reptiles are they have a dry, scaly, keratinized, waterproof skin. They reproduce on land. They don't need water for gas exchange or reproduction. They are the first amniotes to speak of. All of them have three-chambered hearts like adult amphibians until you get to the larger ones where they make a transition to a four-chambered heart that's much more efficient, transporting fully oxygenated blood. These guys, like the amphibians, though, are still ectothermic or rely on the external environment for body heat in order to do chemistry for metabolism. So we are making a transition eventually to being endothermic or warm-blooded, and those two groups are just going to be birds and mammals, both of which rose from reptiles, but not yet. Reptiles are still ectothermic. It is an adaptation for efficiency. So the four-chambered heart that we're going to talk about later, you can start with crocodiles, then you can go to birds and mammals. It is much more efficient at keeping oxygenated and the oxygenated blood completely separate. Amphibians have a three-chambered heart. They can flip the septa inside their heart on and off to shunt off blood to their lungs. Reptiles have a three-chambered heart, and it's just not quite as efficient as a four-chambered heart. But since they're ectothermic, they don't have to have high levels of oxygen, and so this is a heart that works very well for a cold-blooded or ectothermic creature. Finally, when we talk about amniotes, it means that they have specialized complex tissue layers to remove waste, hold nutrients, do gas exchange, and allow a small embryo to develop into a larger creature. The reason this is an advantage is because the more mature, well-developed young you can have, the higher chance of survival that you have as a species. It's just that to do this internally inside the body is very risky, which mammals took on that risk. Reptiles and birds do not. So it's a strategy to have well-developed young for higher chances of survival. Do you do that outside the body or inside the body? More about that next time.